Hello, everyone. I'm happy that I'm here. And I would like to tell you something about GeoPython, how to save the world using Python. So, my name is Małgorzata Niewiem, and I come from Poland, from Kraków. And I'm Python developer at some startup company which is called SATIM, and I am also a PhD student at University of Science and Technology. And I would like to say you something about my works in startup and at university, because I try to merge these things. And so, on the beginning, before I show you some examples about GeoPython, I had to tell you something about the Geo. What is the Geo? What is the basics of these topics? So, if we think Geo, we think that there is the Geographic Information System, which is in short called GIS. It is also cartography. It is land surveying, sometimes called geodesy. It is also the geography, photogrammetry, and it is global navigation system, satellite system. For example, you know the GPS from United States, which is a American global navigation system. And we also know the Galileo, which is the European navigation system. And Geo is the other form of mapping. So, if you think Geo, you think about some position in the world. And you can describe the position using two ways. The first way is the absolute way. Here is on the right side. Absolute means that we describe our position using coordinate system. For example, if you see on the Hong Kong on this map, is it in the middle of the map, on the right middle, and there is the coordinate system called UTM. It is a very popular coordinate system because we use it in the Google Maps, Google Earth, so I think that everybody here uses these coordinate systems. And the other ways to describe the position is relative. It means that we use some text, some numbers to describe our position. So, for example, we use the name of the city, of the country, or the distance between some points. Maybe describing the position using text somewhere in Amazonia is not the best, because, you know, but sometimes it's only the one what we know about our position. So, so maybe it is only one. And in Geo, we have two types of data. We have vector and we have raster. And raster is a simply because it is the table of pixels. But vector is more complicated because we have points, line, polygon, or more advanced types. And here is some examples of this data. You can see the difference between raster and data. Raster is an imagery. It is a remote sensing imagery. Here is the Berlin, and this photo was taken by Sentinel-2 satellite. I will tell you something more about this satellite in next slide. And here on the right, there is the example of vector data. I would like to find some vector from Czech, from your country, but it was difficult to me, so here is the vector of Poland. And if we know what is the Geo, what types of data we have, we also had to know the sources of this data, because it will be very nice to have possibility to download some data and for free and use it. So I would like to show you some example. The first is the web page C-Hub Copernicus, and it is of course for free. You had to create account, but it's also for free. And this web page is developed by European Space Agency. And on this web page, you can download data from the Sentinel mission. But what is the Sentinel mission? It is developed and launched by European Space Agency satellites. And for example, there is the Sentinel-2 satellite, and you can get the data about land to monitor the land. And other web page is the Earth Explorer. It's an American web page. It's developed by USGS. And on this web page, you can download, of course, for free, the data from the mission Landsat, which is a mission from NASA. And it's also for free, so you can use it now and check there. Here are the data for you. And what is worth to mention, the Landsat mission is the longest running mission in the history of acquisition of satellite imagery. The last launched satellite is a Landsat 8. And here is the example of vector data. I think that most of you know this web page, the same as Google Maps. It is an OpenStreetMap. It is for free. So if you want to have some vector, for example, border of your country, of your city, and some street, you can use OpenStreetMap. You can use the API or download directly from the database. Okay, so now we know something about geo, about data, and I say you that I told you something about GeoPython. So you must know that Python is mostly widely used language in the geo users and programmers. But why? I think that you are not surprising, because all of these things on this list is the advantages of Python. So Python is easy to learn. So the most of people who are geo are not programmer. So for them, it's very easy to learn Python. And the Python has, as we see here, the large community. So everybody can help us, I think, and I hope. And here is the list of some Python library using for geo. It is a short list, because I read that there is about 100 libraries for geo, so it's a very, very short list. And the first which I would like to show you is the first on the list, is a GDAL OGR, and it is only one which I want to show you, because there's no enough time to talk about every this library. So GDAL, Geospatial Data Abstraction Library, and OpenGIS reference. And in the next slide, I tell you why we have two names, so GDAL and OpenGIS reference. Because on the beginning of developing this library was GDAL, which was for the raster data, and was OGR, which was for the vector data. But it was developed by the same people, but it was different project. And on the end of this ways, on this project, they merged all of this project both of this project. And now we have one library which consists two libraries. So if you tell GDAL, you also mean about libraries for the vector data. So GDAL is open source, and it is C++ library. So if you are beginners of programming, of learning programming, I don't recommend this library because it will be so strange for the person who don't know C++. I use C++, so for me it was not the problem, but for the beginners I think it will be. So I recommend another library. It is a Raster. And here is some example of using the GDAL library. Here is the code how to read the raster data. You can open this data and you can check the very simple things about this data. For example, the size of raster data and the number of bands. You can also see the information about some statistic of all of these bands. For example, the minimum or maximum value for each band. And I said that we can check the number of bands. Why? Because the remote sensing imagery have more than 3 bands. Not only the RGB, but also have more bands. The number of bands, it depends on sensor who is on the satellite and acquires the wave. So, for example, the Sentinel-2 satellites have 13 bands. For example, has some near-infrared bands. And if we have Landsat, we have only the 8 bands. And when we talk about GeoRaster, we can also check something about the projection of this data. So where is our raster in the world? So we can use the function getProjection, and we know something about our coordinate system. When we use the function getGeoTransform, we can see, for example, the coordinates of our top left corner of this image, and we also see some parameter which is a pixel size. And before I don't tell you about pixel size, but pixel size refers to the size of the smallest object that can be resolved on the ground, but only if the image is displayed at full resolution. So, for example, Sentinel-2 has 10-meter resolution, so the pixels is square 10 meters by 10 meters, and the Landsat has 30 meters, so it's not so big for us now. And on the end of the presentation, I would like to say something about how to use this data, this information. And I show you some project which I was member of the team, and I was a Python developer too. Oh, so if you want to save the world, you can think about some agriculture. Why? Because you can save the money, time, and you produce more food and help in some poorly area. So using geodata, using geo, you can determine soil type, soil moisture. You can also monitor the crop condition to precisely farming. So the first, using the library, here is the raster library, you can calculate the NDVI. And this is the index which tell us something about condition of vegetation. And on the left is the raw data. It is from Kraków. And on the right is the image after calculation, NDVI. And I think it's OK. We can see the colors. It is red and green colors. And what means these palettes of colors? And of course, the red means that there is the bad vegetation here. And the green means that we have very, very good vegetation condition. And on this image, we have red because there is some urban area. So there is a building, so there's no vegetation here. And using this index or advanced and more advanced index, we can create some project. And it was the Agro project. And in this project, I was a Python developer, and we check the dynamics of change in the agricultural land. But why? We support some Polish organization and for agriculture because European Union has the project for farmers. It's called direct payments, and farmers get some money for farming. But the institution, some domestic institution, had to control that everything is fulfilled and money was properly distributed. So they must verify farmers, and we, using the remote sensing imagery, verify this condition. And here is the example. And we have some vector, which was the land of farmers who apply for this direct payment, and we check what is going on this land. And for example, we detect there was some anomalies, and when we go here, it was new building, so it was not properly, and it was not so good that it was so building because they have money for land, not for building. Okay, another project was called SATA Grow. And in the previous project, we help the institution to verify farmers. Now in this project, we help farmers to increase the efficiency of farm. And for example, we developed some application which help farmers to improve their decision. They have information about rainfall, about biomass, about some drought and disaster to help them to maximize the potential of land and, of course, to protect some environment. And if we think about how to save the world, we also think about natural disaster. So using Geo, we can forecast weather to warn about natural disaster. We can prevent the spread of disease. We can monitor air quality, volcanoes, and landslides, ground deformation. And to the end, it is the end project which I want to to show you. And in this project, we're using the information from the Sentinel data. We create some warning system for the inhabitants of areas threatened with ground deformation. It is very popular in Poland that we have a mining, or there was mining, and in this area there is a problem with ground deformation. So we help these people to have some information about ground deformation only based on the information from the satellite data. Now we have some algorithm, and we are developing some web page and some application to help these people. And on this picture, the red means that will be ground deformation about 100 centimeters. And on the end, if you want to check where is your package from AliExpress, you can use the GeoData, for example, the data from the QuickBird satellites, because the spatial resolution is less than 1 meter, so you can see the ship on the sea. And you can also see the royal wedding, if you want, of course. And I think there is everything. Thank you for your attention, and if there are any questions.
Good, thank you very much. So Slido is empty, so I hope that your minds are full of questions. Good. Here's the first one.
Hello, thank you for your presentation. From the code that you show, it looks like it's in Python 2. Is there libraries available in Python 3?
Could you repeat?
So the code that you showed, as I understand it, it was in Python 2?
Yeah.
So are the libraries available in Python 3, the libraries that you showed?
Yes. Maybe I cannot tell about this, but all of these libraries for free in Python.